Welcome, everybody. Thank you for joining this session. My name is Stefano Sandrini. I'm a solutions architect at AWS. And today I'll be talking about how to build a universal GraphQL API to accelerate front-end development. So let's have a look at the agenda for this session. The main topic is how we can use GraphQL and a service called AWS AppSync to build modern APIs that can help developing your application faster. In addition, during the session, we will have a look at some use cases, such as real-time applications, and we'll take a look at some advanced features of AppSync, such as security and authorization for your GraphQL API. So when building a modern application, company needs to focus not only on the front end, but also on how to face several challenges on their back-end side. They need to build efficient APIs that can go anywhere and meet the customers where they are. APIs that are scalable, reusable, APIs that can connect to multiple data sources and be usable by multiple clients. They need to be able to engage with their customers, and that also means delivering the right data at the right time. And last but not least, developer and teams need to be able to develop their application faster. So today, our customers are building three main things: universal APIs to connect applications to multiple data sources, real-time applications, applications that includes chat functionality, fan engagement, and location-aware notifications, and more in general, mobile-first applications. So consumer apps, IoT or connected devices, apps, field services application, and offline support application. So let's have a look now at what is GraphQL, how it works, and what are the main advantages. Let's imagine we have some sort of front-end application you are building where a user can access their data via a web browser and a mobile device. It can be anything, an e-commerce, social media app, a collaboration tool, a chat application. You can pick one. So usually modern applications expose data from backend services using APIs. APIs are a very important construct that connect your front end to the back end. And basically, APIs allow applications to interconnect, interact, and integrate with internal or external services from all sorts. So with traditional APIs, usually multiple endpoints are exposed. These endpoints can access the same data source with different access patterns and different requirements. Sometimes you may have that each endpoint can access a separate data source. So for example, here we have three different databases. We can imagine we have one for orders, one for products, and one for inventory. So let's say we are talking about an e-commerce application. So imagine now that we have users accessing data from different devices, a mobile phone and a laptop. Users log into the system and want to retrieve their data. And in order to do so, they need to access the API endpoints to load the required data to their devices. With traditional APIs, such as REST API, for example, loading the data is done sequentially. First, I need to access the endpoint A to retrieve some of the data and populate the application user interface accordingly. The response payload in a traditional API is usually static. No matter the device I'm using, I'm always going to get the same payload. Maybe it's a big JSON object with tens or even hundreds of fields. But mobile devices have smaller screens, so they need to display less data, while a laptop web browser has more screen size, so it can display more data. However, since the response payload is static, both devices receive the same amount of data from the API endpoint. And the front-end application has to manually pick and choose the fields in the JSON payload it needs to display and discard the rest of the data. So maybe there's data that neither the mobile app nor the web browser need, and this data needs to be discarded. So this is a classic situation that we call overfetching data. At the end of this process, we are successfully load part of the data in our user interface, and we can fill the screen in green, both on mobile device and in the laptop. But there's more work to do. When I want to fill the screen part that is in blue, now I have to load more data to populate that part. Maybe I pick a specific ID I retrieve from the endpoint A, and I need to pass that ID to the endpoint B in order to retrieve some more data. So while I overfetched some data from endpoint A, I also underfetched data, because now I need to make a second API call to the endpoint B to get the full data set that I needed. So same as before, since the response payload is static, both devices receive the same amount of data from the API endpoint. And again, mobile device require considerably less data. So again, I have overfetching. And again, the front-end application has to manually pick and choose the fields in the JSON payload. Finally, I may have a main part of my screen, the one in red, that I need to populate. So again, I'm going to call the endpoint C, and now my data is fully loaded in my application. And now my application users can interact with the full data set. So with a traditional API approach, in order to get the data that I needed, I had to make 3 API calls because I was either overfetching or underfetching data. In each one of these calls, I was getting more data than what I needed from both devices. Now let's take a look at how GraphQL works and why GraphQL is important for modernizing your API and your front-end application. So with GraphQL, I have a single API endpoint exposed to all clients, and I only need to make a single API call. So the client can define the data it needs, and the data is retrieved from multiple data sources automatically for me. At the same time, the mobile app reaches the exact same endpoint of the web application and receives a customized payload with only the data field that it requires, because the client can define the data it needs. So as you can see, the payload sent to the web app and the payload sent to the mobile app have different sizes, which means that network calls are optimized and the payload is reduced according to the client. This also means an easier and faster way for development of my front-end application, because I have only one API request, no business logic for request orchestration, and the payload is exactly the payload that I need. Therefore, there's no need to pick fields from the static payload. I can just focus on building my front-end application, building an engaging user experience, and I can just have the data that I need, nothing more and nothing less. I can also have other APIs or microservices as data sources, as we are showing in the slide. And we can use the GraphQL API as a single interface to connect and aggregate multiple microservices with our application. So we have the GraphQL API acting as a data layer and an interface to connect and communicate seamlessly with multiple backend services. Another important thing to remember is that GraphQL is agnostic to data sources. So that allows you to easily abstract the API from different applications and different data sources. You can have any type of data source behind a GraphQL API. You may have a relational database, a NoSQL database, an HTTP data source, a REST API, it doesn't matter. It's completely fine to mix and match different databases and multiple APIs behind a single GraphQL API. So what exactly is the definition of GraphQL? and how it works on the data modeling part. GraphQL is defined as a query language for APIs, and at the same time, a runtime to fulfill those queries. GraphQL, as the name implies, is a data query language. It uses a typed system that allows you to understand data requirements and get also meaningful errors. And also it makes it easier for you to use the API and to create prototype. You can define a GraphQL API with a schema based on a schema definition language. And this schema, that is called the GraphQL schema, is where you define different types, so different way to model your data, such as the user type you can find in the slide. And you can also define its property fields. You can also define operations for your GraphQL API. So we have three types of GraphQL operations. We have queries that you can use to read data. We have mutations that you can use to modify or write data. And we have subscriptions. Subscriptions are linked to mutations and allows you to send real-time notifications to subscribed clients whenever data is changed by a mutation. Also, you can see in the blue boxes what is called the selection set. The selection set represents the collection of fields you define to be returned in a GraphQL operation. And this collection of fields is defined at the client side. So when a client performs a query, let's say the get post query we can find in the slides, it may require as a response just the ID and title fields. When perform a create post, it may require as a response payload just the ID and the date. And same thing for subscriptions. When the client subscribe to a real-time notification related to the onCreate post mutation, it can receive just the ID, the title, and the author. This is very important because, again, this is the way that clients can specify what is the data that they need, nothing more and nothing less. So, for example, a mobile device can specify a smaller selection set than a web browser desktop application. We talk about GraphQL. Now it's time to talk about AWS AppSync, how it works, and how it can be used together with GraphQL to create modern APIs for your front-end application. So AppSync is a managed serverless GraphQL service. It connects to resources in your AWS account, and that allows you to make your data available also in real time and in an offline situation. It can be used as a GraphQL facade to any AWS service. It allows you to perform conflict detection and resolution in the cloud instead of doing it in the client. So again, it's a way to simplify your client-side development. AppSync also integrates with enterprise security features such as identity and access management, Cognito user pools, OpenID Connect compliant provider, or you can use API keys. So how exactly AWS AppSync works? Again, you may have multiple types of application you are developing, front-end application, web, mobile, real-time dashboard, application that shows data in real time coming from sensors from IoT devices, or offline first applications. These applications interact with the single API endpoint provided by AppSync. And then through AppSync, you can access data directly from natively supported data sources. You may access data from DynamoDB tables, from Aurora serverless databases, or Elasticsearch clusters. Your front-end applications through AppSync can also access anything you have in your account using Lambda functions, or even REST APIs using HTTP type of data sources. You can also use HTTP type of data sources to connect directly your application through AppSync to other AWS services, such as step functions or event bridge, using the original endpoints. So again, that's how you can use AppSync as a GraphQL facade to any AWS service. It's also possible to use what is called the local resolver, and we can think about the local resolver as a kind of a pub sub-channel when where the data is not persisted. So you may have front-end applications and you want to send message between clients. You don't want to persist messages in any data source. You can use this type of data source and using it as a pub sub-channel. So how can I get started using AppSync and GraphQL? To get started, you need to model and define your data in the GraphQL schema. The data model in the schema also tells API consumers, so for example, your front-end application, what data is exposed to authorized clients, and it also acts as a kind of an automatically generated API documentation. We also mentioned that GraphQL has a built-in runtime component where developers can customize their own business logic, and that business logic it is executed at the API layer. These runtime components are called resolvers, and basically they provide the logical glue between the data defined in the GraphQL schema and the data that is actually in the data sources. And using resolvers, you can map an operation or even a single field of a type that it is defined in your GraphQL schema with a specific data source. And that allows you to retrieve data for different fields in different data sources with a single API call. So again, these are the main components in an AppSync API. The GraphQL schema, when we define our data modeling and the data that is exposed to API consumers. The resolvers, where we have the business logic running at the API layer, and data sources. So we talk about resolvers, so let's have a look at a simple resolver example. So let's say we have in our GraphQL schema type post that basically models a post in a classic blog application. So we have a type post with some fields. Some of them are required, some of them are strings, some others are integer. Let's say we want to create a resolver to write a new post on a DynamoDB table. With AWS AppSync, you can leverage velocity templates. So you can write request and response template to transform, for example, the GraphQL request into the request with the right payload for the right data source. So in this specific scenario, with the payload for DynamoDB. So, and this is how you can write the velocity template resolver for a write request for a mutation. It performs a put item on a DynamoDB. It provides the payload, so the attribute values for fields that need to be stored in DynamoDB by retrieving data from the payload of the incoming GraphQL request. Of course, things can be more complex. You may want to add if-then statements, default values, and conditional expression. So here we have another example of a put item operation, but with more complexity and more conditional statements. We mentioned that AppSync leverages velocity template or VTL to provide a fast compute runtime layer to resolve GraphQL queries or fields. Sometimes you may want to use what is called the direct Lambda resolvers. So basically, if I have an AWS Lambda function as a data source, I can use what is called the direct Lambda resolvers, which makes velocity templates optional. So it makes basically easier to work with Lambda and GraphQL. giving you more flexibility when developing GraphQL Resolver on AppSync with Lambda data sources, because you can use your programming language or runtime of choice to define your GraphQL Resolver business logic, because that business logic will reside in the AWS Lambda function and not in the velocity template resolvers. And if I'm using an AWS Lambda function as a data source, I can also access securely any VPC resource I may have in my account. So for example, I may want to use a Lambda function to query a relational databases running on Amazon RDS or Amazon Aurora. Or maybe I want to use an AWS Lambda function to invoke an application load balancer endpoint to interact with Fargate, Amazon ECS, or Amazon EKS. So AWS Lambda is the data source that you need to use if you want to access VPC resources or resources that are not natively supported by AWS AppSync. So when I use the direct Lambda resolver, the VTL is disabled. AppSync automatically sends the full context object of the API request call directly to the Lambda function. And the context object contains data related to authorization, identity, query arguments, request headers, as well as the info object. So here we have an example of an info object. In addition to providing the field name, parent name, variables of a query, the info object also exposes details about the selection set. And that makes possible to make calls to data sources that are fine-tuned based on the expected data from the client. So based on the selection set. So for example, the info object comes handy when a type is backed by a primary data source and is also composed of fields whose types are backed by other data sources. So let's say, for example, that we have an application data, and data is stored in a SQL database hosted on Amazon RDS. We may have a post type and a comment type, and post and comment entries are stored respectively in the RDS table posts and the RDS table comments. And let's say we also have a get post query, a GraphQL query, and that query is attached to a direct Lambda resolver to query the relational database. Because again, as we mentioned, you need an AWS Lambda function to query a relational database on Amazon RDS. If we invoke this get post query with the specific selection set you may find in the slides, we receive an info object like this one. So again, we have the field name, get post, parent type name query. We may receive variables, so for example, the ID of the post, and then we can receive the selection set list. So what our clients are requesting: ID, content, and then the list of comments with the ID and the content. Why this is so important? It's important because then in the Lambda function that it is invoked, we can create a specific business logic that can return the right data. And it is very efficient because it can interact just with the data source that it is needed. So for example, what I can do in the Lambda function, I can double check if I have comments in the selection set. If I don't have any comments, I just need to query the post table and return the post table because I don't need to return comments. While on the other side, if I need to return comments as well, after query the post table, I need to query the comments table by using the post ID. So again, this is a very efficient way to be efficient both on the backend side, because I can interact just with the data source that I need to interact with. But on the other side, it's a way to be very efficient also on the front-end side, because again, I can just retrieve the data that I need, depending on the view that I'm building on my front-end application. So let's stretch the concept a bit with another specific scenario, like an e-commerce system. So we can imagine there are different services in the application backend, and these different services are accessible using different technologies. I may have user data stored in DynamoDB, highly scalable NoSQL table. Orders are accessed through a REST API. The current inventory stock is checked using a Lambda function. And pricing information is in a SQL database using Amazon Aurora Serverless, for example. So with a classic and traditional API approach, such as a REST approach, client applications would have to make 4 or even more than 4 different API calls to each of these services. And these calls are using different API endpoints. And again, this increases the complexity on the client side. Also, again, we will find our front-end application in the same scenario we mentioned earlier. We can either overfetching or underfetching data, and the complexity at the front-end layer is increasing. So what we can do with GraphQL and AppSync, we can again combine features from both AWS AppSync and GraphQL using one single API endpoint that can retrieve data from multiple data sources with one single API request. So with a single network call and from a single endpoint, we can retrieve data from DynamoDB, from Amazon API Gateway, from AWS Lambda, and from Amazon Aurora. And what clients receive is just a single payload, receiving user profiles and orders depending on the selection set requested. And again, everything is just with one single network call from a single API endpoint. And the backend complexity is abstracted. Also, a front-end development team or API consumer team can add new features or even new application without basically waiting for a specific backend team to implement new APIs. And also, since GraphQL is self-documented and can leverage introspection, the introspection make it easy for front-end development team to learn what data is available from the single unified GraphQL endpoint. So again, with one single request, with one single endpoint, I can retrieve just the data that I need, nothing more, nothing less, and the backend complexity is abstracted. Of course, talking about front-end application that leverages API and backends, we need to talk about security and authorization. With AWS AppSync, you can create GraphQL APIs that can be used by the application. And this interaction is over the internet. So API endpoints are publicly reachable. But while the API endpoints are publicly reachable, they never allow unauthorized access. A method of authorization, a token in the request header, or for example, signing the request itself with AWS credentials, is always required to access your AppSync API. So with AWS AppSync, you can create GraphQL APIs that can leverage one or more authorization method, and these are what is available for you. You may use API keys. You may want to use Amazon Cognito User Pool, OpenID Connect compliant provider, identity and access management, or even AWS Lambda. AppSync APIs must have a default authorization mode defined globally, but it's also possible to add additional authorization mode in the same API, as well as mix and match these modes, linking, for example, specific authorization providers to specific types, field of operation in the GraphQL schema. And in order to do so, you can use AppSync specific directives to configure authorization and security at your data definition layer directly in the schema. So here we have an example with a flight type, so a kind of a flight type of application. So the type flight is defined in the GraphQL schema, and we define Cognito User Pool as the default authorization mode in the API. So when a user is part, in this specific example, of the Cognito group frequent flyers, can actually access all data from type flight, all fields. But maybe we need to expose specific fields in the flight type for guest users. Guest users are not logged in users, so they're not part of a Cognito User Pool. They will connect probably using an API key. So we can say when the request is invoked using an API key, the departure airport code and departure airport name and the ID are exposed to the client. And also we can say that we want to add also identity and access management authorization mode. So again, if the request use identity and access management, fields available are the ID, the arrival airport code, the arrival airport name, the arrival city, and the arrival locale. So when do I have to use each specific authorization mode? What are the use case for selecting the right authorization mode? Let's start with API key. API key use the HTTP header X API key. Usually API key are hard-coded in the application. So that means that usually you're going to use API key for getting started with your development. So you are in the development phase, you don't have user management already built in your application. You can just use the API key. When you want to create some sort of public APIs, so if you remember, you must have a default authorization mode defined for the AWS AppSync API. So the closest scenario to a public API is the one related to the API key because it's hard-coded in the application. Or you can use API key again when you don't have any specific authorization requirements. For example, when you are modeling a guest user. Then we mentioned that you have Cognito User Pool. So you are managing your application users using Cognito. Cognito will provide a JSON web token that specify claims and attributes of your users. And you can use the integration with Cognito User Pool to create granular access control with leveraging AWS AppSync directives. So for example, here in the slide, we have a directive that specifies that the list of posts, so a specific post query, can be performed by users that are part either of the bloggers group or the readers group. So when to use Cognito User Pool? When you are managing Cognito for authenticating user in your application, when you want to connect your user with social identities, for example, and when leveraging the JWT provided by Cognito, you want to interact with other AWS services as well. You can also use OpenID Connect authorization mode, still JSON web token provided by an OIDC identity provider. You can perform granular access control based on claims. So at resolver layer, you can inspect claims, inspect what are groups containing claims, and again, if the user is part either of the bloggers group or the readers group, then the user is authorized, otherwise it's not authorized. So I can perform granular access at the resolver layer. When to use OpenID Connect? Usually when you have an already existing user directory that leverage an OpenID Connect identity provider. Again, you are authenticating user in-app, but with the same JWT token, you don't want to interact with other AWS services. We mentioned also identity and access management. Basically, this is the classic scenario when you want to do machine-to-machine integration, so backend systems that leverage AWS credentials to interact with your GraphQL API provided by AppSync. So for example, IoT systems that sends data to a GraphQL endpoint, and you can basically leverage IAM policies to specify access to the API. So classic examples is an EC2 instance or a Lambda function. And again, you can specify policies at the execution role of identity access management. So by mixing multiple authorization on type, operation, and field level, leveraging the default authorization mode, and leveraging additional authorization provider, you can address your specific scenario for your front-end application that leverage a GraphQL API. We mentioned also about a classic use case, and we already mentioned that you can use GraphQL API as a facade to multiple data sources you may have, or maybe multiple microservices that you may have in your backend. But another classic example is real-time use cases and real-time applications. So you basically can leverage AWS AppSync to enable scalable real-time collaboration use cases. So maybe collaboration tool or chat application. AppSync takes advantage of GraphQL subscriptions to perform real-time operations by pushing data to clients that choose to listen to specific events from backend. You can have thousands or even millions of clients subscribe to a specific mutation on AppSync. So, and that means that you can easily make any supported data source in AWS a real-time data source. And the connection management is handled automatically for you by AppSync to the client and the service. And that means that a backend can easily broadcast data to connected clients, or clients can send data to other clients, depending on the use case, in an easy way. When a client invokes a GraphQL subscription, a secure WebSocket connection is automatically established and managed by AWS AppSync. And that connection will remain constantly connected to your backend. So how does it work in practice? After authorized clients make a subscription call that is linked to a specific mutation, a WebSocket connection is established, providing a secure channel between the client and AppSync. Clients can also be subscribed to multiple mutation, and the related subscriptions all share the same WebSocket channel. So in this specific example, we have multiple clients, mobile clients, web clients, desktop clients, all connected to the same AppSync single endpoint. And we have a single DynamoDB table as a data source, but that's not important. It works the same way with any supported AWS AppSync data source. So if a client executes a mutation, for instance, a create post or a create message, let's say on chat application. That mutation is invoked against the single GraphQL API endpoint in AppSync. AppSync then perform authorization checks and then execute any business logic that is defined in the resolver. And then it sends a request to DynamoDB to create an item in the table. So it performs, in this specific scenario, a put item in the table. After the data is saved to the data source, AppSync automatically broadcasts data to all connected clients. And each client can have a different selection set defined. So for example, let's say a mobile client might just need an ID and the title, while a web client may have the ID, the title, and the descriptions. So again, that's a very efficient way for clients to just receive the data they need. Arguments can also be defined in the subscription, and that means that, let's say you don't want to broadcast to all clients a message. You can basically define clients listening just for a particular ID. For instance, on a chat application, you may want to listen just for a chat group ID and just receive new messages for that specific group. Very classic scenario. And if we stretch the concept a bit, in the same sense, this can be done in a one-to-one fashion. So only one client receives subscription data. So again, thinking about the chat application, we may have one-to-one private conversation, and only users in that specific private conversation can receive the message. So this is how clients, front-end application, can easily interact by sending messages to other clients, not just chat messaging, of course, but also, again, collaboration tool payload, for example. It can be either one-to-one or one-to-many. But what about backend data? How can I push backend data to connected clients, to connected front ends? I may have a backend process. For example, I may have a Lambda function, and that backend process executes a mutation against AppSync. So again, we are in a situation that is same as before. AppSync sends a request to DynamoDB after performing authorization check and executing resolver business logic. Then it performs the put item on a DynamoDB, and after the data is saved to the data source, AppSync automatically broadcasts data to all connected subscribed clients. So as you notice, AppSync needs to be aware of a mutation in order to send subscription data. So what happens if I already have a system, I want to create a new application, a new front-end application that wants to be notified in real time, but the legacy system already writes data in DynamoDB without using any AWS AppSync mutation. So let's say if we have a backend process that writes directly to DynamoDB, this is what we call an out-of-band request. What we can do, we can consume a DynamoDB string, for example, using a Lambda function, and then the Lambda function again performs a mutation against AppSync. Of course, now we don't want to save data twice, and we don't want to overwrite data to DynamoDB. And here's when local resolvers comes handy. Local resolvers are internal to AppSync, and they work as a pub/sub channel, as mentioned earlier, and no data is persisted. So the local resolver is executed successfully, and then data is broadcasted to all subscribed clients. So using AppSync is also a very efficient way to empower real-time collaboration front-end application with simplicity, because the real-time data management, connection management, scalability, fan-out, broadcasting of data, all these things are handled by AppSync. So your teams can just focus on front-end application, building your business use cases, and building your requirements and focusing on requirements, instead of dealing with the complexity of infrastructure management and WebSocket connection management at scale. Managed GraphQL with AppSync is being used by multiple companies across multiple industries. from BMW Group to Aldo. BMW leveraged GraphQL using AppSync to build scalable and universal APIs for data providers and consumers. Peacock is a streaming service launched by the Comcast Corporation that use GraphQL APIs provided by AWS AppSync. And again, AWS AppSync allowed Aldo to focus on implementing features in their application instead of managing their system and its infrastructure. And this adds velocity in the development of front-end applications. Also, customers in the media are using GraphQL API provided by AppSync. For example, Sky Italia. They wanted to deliver a better fan experience by pushing real-time data updates during live broadcasts of sports events. And after deploying the new version of their API that leveraged AppSync, they decreased the time needed to propagate game data in real time to users from a few minutes to milliseconds. And also, they saw their cost reduced over 30%, and they expect even bigger savings in the future. In conclusion, I encourage you to visit our resources page to learn more about AppSync, how to get started. We have a website, we have documentation, we have a GitHub repo where you can find samples. We have a blog channel, and we have multiple resources that you can visit. Thank you for joining the session. This session was focused on how to build a universal GraphQL API to accelerate front-end development. I hope you enjoyed the presentation. My name is Stefano Sandrini. I'm a solutions architect at AWS, and thank you again for joining the session.